So now another experiment which you can do on this four-cylinder petrol engine test rig is the heat balance test, right? So what is this heat balance test? So we know that we are supplying fuel to the engine, and the fuel undergoes combustion inside the cylinder and it liberates its calorific value, the heat content. So that is the energy input given to the engine. And I know by thermodynamic principles, all this input energy cannot be converted into work. So according to the second law of thermodynamics, there is no heat engine which can have 100% efficiency. That means this engine converts only part of the heat input as the output power. So in the heat balance test, what I am trying to find out is what happens to the remaining energy. And I know that some of the heat is lost for cooling the engine. So the engine always runs very hot. So that means we need to provide sufficient cooling. So this cooling water takes some amount of water, some amount of heat. So I am just trying to find out how much heat is in the coolant and how much heat is in the exhaust. All this I am trying to find out, and finally putting it in the form of a graph, which is what is known as the heat balance sheet, right? So with the help of the heat balance sheet, I know how much energy is in exhaust, how much energy is in coolant, how much energy is lost through friction and other means, so that I can design some energy recovery systems from the engine, so that I can improve the overall efficiency of the engine. So here in this experiment, you will be asked to do the experiment under different loads, like no load, 10 kg, 20 kg, 30 kg, 40 kg, like that. So which load you are required to do, so that will be given in the question paper. So accordingly you need to proceed. So what are all the various readings that are required to be taken? So now let us say the engine runs at no load. This again you have to do under constant speed. So that means the speed is set at 1000 rpm, right? First thing is I need to find out what is the energy input to the engine. For calculating the energy input, how much fuel the engine consumes. For zero load, just note down what is the time taken for 20 ml of fuel consumption. As explained before, just make two lines which corresponds to 20 ml and just note down what is the time taken. So with this I will be able to find out what is the heat input to the engine. So now I need to calculate how much heat is carried away by the coolant, right? So for coolant I need to measure what is the inlet temperature to the engine jacket and what is the outlet temperature from the engine jacket. T1 and T2, that is required to be calculated, and also I need to find out what is the mass flow rate of the cooling water. So totally the heat lost in the coolant is mass flow rate into specific heat of water, that is approximately 4.18 or 4.2 multiplied by delta T, right? Delta T is the T2 minus T1. So measuring all the temperatures, so there are temperature sensors are available. For example, so this gives me the water outlet temperature. So there is a RTD sensor is there. Similarly, so there is at the inlet point also there will be a temperature indicator, that is actually the exhaust gas calorimeter. So the temperature T1 and T2, there will be temperature sensors will be there. Finally you are noting down all the temperatures here only. So this is the digital indicator which gives you the temperatures at different locations. Just by pressing the switches here, now it gives you T1. So you can set at different positions. So this is T1.
Yeah. It has to be pressed simultaneously.
Okay.
That's what he said.
Okay. That is it. You have to start from 0, 0. Okay. Yeah, 0, 0. Now you want to find out T1. Press both the switches. It is going to T9. Yeah, now 0, 0. Press both the top switches together, you get T1. and again you press it, you will get T2. So like that you are finding the T1 and T2, and for measuring the water flow rate, right, you have two rotometers. So one is for the engine and one is for the calorimeter. So basically there is a float which is there, and the top surface of the float, right. So what is the reading? So that directly, this is given in liters per hour. So directly you can take the reading in liters per hour, right. So that completes your calculation for the heat loss in the coolant. Now, how to estimate how much heat is there in the exhaust gases? So for which I need to again measure what is the mass flow rate of the gases, specific heat, and the delta T for the gas, the inlet temperature and the outlet temperature of the exhaust gas. So for measuring the heat in the exhaust, there is a calorimeter, right? So this one is an exhaust gas calorimeter. So it's basically a shell and tube type heat exchanger. So the exhaust gases which leaves the engine from the exhaust manifold enters into the calorimeter and gets cooled by the circulated water, and finally it leaves to the atmosphere through this tubes. So here basically what happens is the gases are cooled with the help of the water. So I am just making an energy balance, noting that the heat lost by the gases is equal to the heat gained by the water, right. MC into delta T for the water is equal to MC delta T for the gases. So what is the inlet temperature to the calorimeter and outlet temperature of the water to the calorimeter? What is the inlet temperature of the gas to the calorimeter? What is the outlet temperature of the gas from the calorimeter? So all these temperatures are noted down, and making the energy balance, I am just first finding MC of the exhaust gases. Using the energy balance, you are finding what is the mass flow rate and the specific heat of the exhaust gases. Then what is the heat lost in the exhaust gases? MC of the exhaust gases multiplied by the temperature of the exhaust gas minus the ambient temperature will give you the heat in the exhaust. So like this, the various temperatures are also found out. The exhaust gas inlet temperature is T3, exhaust gas temperature outlet temperature is T4. This is for the calorimeter. Calorimeter for gas inlet temperature is T3, for calorimeter gas outlet temperature is T4. Water inlet temperature is T5, water outlet temperature is T6. By making the energy balance, you can find out the MC of the gases, and ambient temperature is also there, and the exhaust gas inlet temperature to the calorimeter is the gas temperature which leaves the engine, right. So that MC of the exhaust gases into T3 minus T7 will give you the heat in the exhaust. And so these three you have calculated, and the remaining amount of heat is basically lost in the radiation, convection and friction. So these are all the things which I am not calculating it separately. I am just grouping everything together and I am saying it is unaccounted loss, right. So the total heat input minus summing up all the heats, that is heat equivalent to the brake power, heat lost in the exhaust gases, heat lost in the coolant, together the remaining heat is taken as the unaccounted loss, right. So finally you drawing the heat balance chart by taking the brake power or the load in the x-axis and the cumulative percentages in the y-axis, you are drawing the heat balance sheet. So this has to be done, the same readings has to be taken for different loads as mentioned in your question. So that completes this exercise.